Hello and welcome. Today, we're diving into the incredible world of composite materials. Now, you might not know it, but these things are the unsung heroes of modern engineering. They're basically hiding in plain sight in everything from skyscrapers to the jacket you're wearing. So let's get right into it. So, what do these three things have in common? It sounds a bit like a riddle, right? But the answer is the key to this whole explainer. Every single one of them relies on this brilliant idea of taking different materials and combining them to create something way, way better than its individual parts. Stick with me and you'll see exactly what I mean. To really get our heads around what a composite is, we need to hop in a time machine. We're going to go back and look at a huge problem that stumped builders for centuries. And it all starts with one of the most common materials on the planet, concrete. Okay, so concrete has a superpower. It has incredible compressive strength. That's a fancy way of saying you can pile a ridiculous amount of weight on top of it and it just won't care. That's why we use it for foundations, right? It's amazing at being squashed. But, and this is a big but, it has a fatal flaw. The moment you try to bend it or pull it apart, it's surprisingly weak. Under that kind of pulling force, what engineers call tension, it's brittle. It just snaps. And for early builders, this was a massive headache. The solution, like a lot of great ideas, came from just one person paying attention. Back in the 1850s, there was this plasterer, a Mr. Wilkinson, and he just kept noticing that the concrete floors he was laying would get these annoying cracks. And he had this light bulb moment. He realized the cracks were showing up where the concrete was being pulled and stretched. So he thought, well, what's good at being pulled? And he grabbed some old metal barrel hoops, the things that hold a wooden barrel together, and he just put them inside the concrete right where it was weakest. Now, here's why this was so genius. Look at how these two materials behave. Concrete is strong when you squash it. Steel is strong when you stretch it. Concrete cracks, steel bends. They perfectly cancel out each other's weaknesses. But here's the real magic trick. They both expand and contract from heat at almost the exact same rate. If they didn't, the whole thing would just tear itself apart as the weather changed. It's a perfect partnership. And just like that, in 1853, Mr. Wilkinson created reinforced concrete. It seems so simple to us now, doesn't it? But that one idea literally built the foundations of our modern world. Our cities, with their soaring skyscrapers, simply could not exist without it. So, that whole story is the perfect setup for our main topic. See, Mr. Wilkinson didn't discover a new material, he designed one. And that gets us to the big question. What actually makes something a composite? Okay, so here's the official definition. At its core, a composite isn't just a mix, like stirring sugar into your coffee. It's about taking at least two really different materials and putting them together in a way that gives you a totally new material with the best properties of both. And that word, complement, is everything. This isn't about finding a happy medium. It's about one material's strength directly fixing another material's weakness. The steel's ability to be pulled perfectly complements the concrete's ability to be squashed. That's the core principle of every single composite out there. All right, now that we've got the theory down, let's take a quick look around. Because once you know what to look for, you'll start seeing these designed materials absolutely everywhere. First up, a classic. Fiberglass. It's made of too many things. You've got these tiny, super strong strands of glass, and you've got a lightweight plastic or polymer. By themselves, the glass is strong, but it would shatter, and the plastic is light, but it's kind of flimsy. But you mix them together and you get fiberglass, a material that is both strong and lightweight. It's the perfect combo for something like a kayak, which has to be tough enough to bump into rocks, but light enough for you to actually carry it to the water. Okay, let's level up to something a little more high-tech. Carbon fiber. You've heard of it, right? On its own, carbon fiber is made of these threads that are unbelievably strong and light, but they're also kind of floppy, like fabric. So you combine them with a polymer resin that's really stiff, but honestly pretty brittle and weak on its own. And the result? You get a material that is stiff, crazy strong, and super lightweight all at the same time. That combination is basically the holy grail for performance engineering. It's why you find it in elite racing bikes, Formula One cars, anything where every single gram counts. Composites even solve problems you find in your closet. You know how a cheap plastic raincoat keeps the rain out, but it also traps all your sweat so you end up soaked anyway? The solution is a composite fabric. It's made of multiple layers designed to be a one-way street.
The holes are too small for big raindrops to get in, but they're big enough to let tiny water vapor molecules from your sweat get out. Genius.
And finally, here's a composite I can almost guarantee you have in your house right now. MDF. It's really just leftover wood fibers, basically sawdust, all mixed up with a strong glue. That combo creates a super cheap, smooth, and really stable material that's perfect for things like IKEA bookshelves and kitchen cabinets. Now, with all this talk of carbon fiber and advanced polymers, it's pretty easy to think that composites are a super modern invention. But you'd be wrong. The basic idea is actually ancient. I mean, look at this. Humans have been making composites for thousands of years. The ancient Egyptians mixed straw into their mud bricks. The straw did the exact same job as the steel and concrete. The Mesopotamians were making plywood all the way back in 3400 BC. They even used sticky rice in the mortar for the Great Wall of China to make it stronger. It wasn't until the 1900s that we started playing with synthetic plastics, which gave us modern composites like bakelite and, a bit later, fiberglass.
So, we've seen how they work, we've seen where they are, and we've seen that this idea has been around forever. And all of that brings us to the final, and I think the most important point. This is the big idea right here. We are no longer limited to just the materials we can dig out of the ground or chop down. By understanding how different materials work, we can combine them in really clever ways to invent entirely new materials. Materials that are tailor-made to solve a very specific problem, whether that problem is a cracking floor, a heavy boat, or just a sweaty jacket. And that really leaves us with a fascinating question to think about. We're facing all these huge new challenges, from building habitats on Mars to developing cleaner energy sources here on Earth. The solution to some of those problems might not be a material we already have, but a composite that we haven't even dreamed up yet. Thanks for watching.